Hello, our esteemed viewers. In today's math tutorial, we want to find the range of values of x that satisfy the inequality 4 minus x over 4 plus x less than 2 plus x over 2 minus x. If this were to be an equation, we would have cross multiplied this way. However, with inequality, we need to take caution in the sense that if we multiply by 4 plus x, for instance, since the value of x is not known, we may not be able to tell what becomes of the inequality sign. Likewise, 2 minus x, because, for instance, if we multiply through by a negative number, the inequality symbol should change. Therefore, an escape route to this kind of problem is to multiply both sides by the square of each of the denominator. The reason for this is not far-fetched. It is because the square of a number can never be negative, even if the number is negative. So multiplying by the squares of these denominators erase any fears of having the inequality symbol changed. Therefore, we will be having 4 minus x over 4 plus x multiplying 4 plus x squared and 2 minus x squared on the left hand side, and this is less than 2 plus x over 2 minus x, also multiplying 4 plus x squared and 2 minus x squared. Then 4 plus x here takes one of this away, while 2 minus x on the right hand side takes one of the 2 minus x squared away, leaving us with 4 minus x, 4 plus x, and that multiplying 2 minus x squared on the left hand side, and that is less than 2 plus x, 2 minus x, and 4 plus x squared on the right hand side. Now, at this point, we are going to transfer everything on the right hand side to the left, thus leaving us with 4 minus x multiplying 4 plus x multiplying 2 minus x squared, then minus everything on the right, which is 2 plus x, 2 minus x, 4 plus x all squared, less than 0. If you are yet to subscribe to this channel, please do so now and click on the notification bell so that you can be updated from time to time about our math tutorials. Then we have some common factors now that we have reduced the inequality to this expression and this expression. So we can factor out 4 plus x and 2 minus x. While we open a bracket, then we'll be having 4 minus x, 2 minus x, then minus 2 plus x, 4 plus x, less than 0. We open the brackets which are in the big bracket. Then 4 plus x, we are going to write it as x plus 4. 2 minus x is written as minus x plus 2. And in the big bracket, the first product, 4 minus x and 2 minus x, will give us 8 minus 6x plus x squared, minus the second product, 2 plus x and 4 plus x, we put them in the bracket first because of the negative outside the bracket, to give us 8 plus 6x plus x squared, and everything is less than 0. Now from here we can factor negative such that we have minus x plus 4, x minus 2 having factored the negative, and in the big bracket we will be having 8 minus 6x plus x squared. Then using this minus to open up the bracket after it, we have minus 8 minus 6x minus x squared. Everything is less than 0. Then in the big bracket, 8 takes out minus 8, x squared takes out x squared, leaving us with a product minus into bracket x plus 4 times x minus 2 times negative 12x. Now the negative sign before 12x and x plus 4 cancel out, such that we have, rearranging, 12x times x plus 4 times x minus 2 is less than 0. We can divide through by 12, leaving us with the product x plus 4 and x minus 2 less than 0. Now at this point, being inequality, we will advise you watch to the very end as we examine the options for the solution. Now we are going to examine the different ranges that could possibly give us the solution using this table. Now in this table, we have x plus 4, x minus 2, then their product here, as we have in the inequality above. And this is going to be for our remark. And to the left here, the values we have in the resulting inequality, we've got x. If treated as an equation, we could say x equals to 0, x plus 4 could be x equals to minus 4, and x minus 2 could be x equals to 2. And because of that, we'll be considering, being an inequality, values x less than minus 4. We'll consider x lying between negative 4 and 0. We will consider x lying between 0 and 2, and we consider situations where x is greater than 2. Then we find the corresponding values of x plus 4, and x minus 2, whether they be positive or negative, and equally their product. So when x is less than 4, the value of x is negative. The value of x plus 4 is negative, and x minus 2 is equally negative, meaning that the product will also be negative. What then would be our remark? A look at the inequality says that the product must be less than 0, which means that the product must be negative. And since the product here is negative, when considering x less than minus 4, then it means that x less than minus 4 is a solution. We denote that with a yes. For values of x between minus 4 and 0, let's say we try minus 2. X will be negative, x plus 4 is positive, x minus 2 is negative, leaving us with a positive product for the 3. This is a no, as it is greater than 0. Now for x lying between 0 and 2, x is positive, x plus 4 is positive, but x minus 2, let's say we try 1, is going to be negative. And as a result, the product is negative. That is another yes for the range of values for the solution. Then for values of x greater than 2, say 3, x is positive, x plus 4 is positive, and x minus 2 is positive. That gives a positive product, which is a no. We can see from this table that the range of solutions, range of values of x that satisfy the given inequality are x less than negative 4 and 0 less than x less than 2. Therefore, we can say that the solutions or the range of values that satisfy the inequality are as given in this interval. They are open interval. For x less than minus 4, it is the interval negative infinity, comma, negative 4. Union for 0 less than x less than 2, we have the open interval 0, comma, 2. Hope you enjoyed the tutorial. Please give the video a like. Share your thoughts with us in the comments box. Share the video and subscribe to the channel if you are yet to do so.